Welcome to this video. So this is the fourth video of KCET 2018. Here in this video I'm going to discuss question number 16 to question number 20, right? So question number 16 is, which of the following oxides show electrical properties like metals? So they have given ABCD options. These are oxides. We have to tell which one will show electrical property like metal, right? So this SiO2 is nothing but this sand. So you know that sand is what insulator it is not going to conduct electricity, so it is insulator, so it is not going to show any electrical property, so it is not the option. Magnesium oxides, so these are not going to show any thing, right? Electrical property. It is the sulfur dioxide in solid state, it is also not going to show. But this is transition metal oxides show electrical property. They conduct the electricity, so they show electrical property, right? So this you have studied in the D and F chapter, in which they will tell that transition metal oxides will have electrical property. It means they are going to conduct the electricity. So answer is fourth one, that is D. Talking about 17th question, see the 17th question is, which of the following aqueous solution, right, which of the following aqueous solution shows what highest boiling point? So they have given options A, B, C, D. C. 1 molar NaOH, 1 molar sodium sulfate, 1 molar ammonium nitrate, 1 molar potassium nitrate, right? So they have given A, B, C, D option. We have to tell which will have highest boiling point, right? So in the chapter solutions, you have studied about colligative properties. What properties? Colligative properties, in which they tell that colligative properties are the properties which depends upon the number of solute particles, right? Number of solute particles, not on the nature or not on the size of solute, or size of solute. The colligative properties only depends upon number of solute particles, but not on the nature nor the size of solute, right? So if number of solute particles is more, then colligative properties are more. If colligative properties are more, in colligative properties we will learn 4, in which one will be the elevation in boiling point. Elevation in boiling point is a colligative property. If number of solute particles are more, colligative property will be more, hence the boiling point will be more. So elevation in boiling point is nothing but there is increase in boiling point, so that will be more, right? So we have to see this is also 1 molar, so we will forget about the concentration, just we will look into this. So NaOH, if I put it in water, it forms Na plus OH minus. How many ions it will going to do? 2 ions. And here Na2SO4, if I put 2 Na plus and SO4 2 minus, so this is 1 ion and 2 Na plus, so 1 ion plus 2, so 3 ions I am going to get it. In option C we see that ammonium nitrate, if I put in water, I'll get ammonium plus NO3 minus nitrate, so I'll get 2 ions. One is ammonium ion, other one is nitrate ion. Fourth, KNO3, if I, that is potassium nitrate, if I put, I'll get K plus and NO3 minus, so 1 ion and 2 ion. So here I am going to get 2 ions. So we know that number of solute particles means number of ions is more, where at B option, the number of Na2SO4 will get how many ions? 3 ions. Since more number of ions, so the elevation in boiling point will be more. So within these 4 options, which is having highest boiling point? Na2SO4. So option B is the correct option. So this is about question number 17. Talking about question number 18th, the charge required for the reduction of 1 mole of MnO4 minus 2 MnO2, that we have to go for, right? So see, we know that charge of 1 electron is how much? 1.6 into 10 to the power minus 19 coulomb, right? So charge of 1 mole of electron means, see, 1 mole means how many particles? 6.022 into 10 to the power 23 particles will be there, right? So this much electrons will be there. Charge of 1 electron is 1.6 into 10 to the power minus 19. So charge of 1 mole of electron will be 6.022 into 10 to the power 23 electrons, into each electron means 1.6 into 10 to the power minus 19 coulomb. That the value will be almost 96500 coulomb, which we call it as 1 Faraday. So many times they will ask what is 1 Faraday. 1 Faraday is nothing but the charge of 1 mole of electrons. So how we got it is 1 Faraday. 1 Faraday is also equal to 96500. How this value came? Because 1 mole means 6.023 into 10 to the power 23 into 1.6 charge of each electron. So 1 mole of electron will get to be 96500. That is nothing but the 1 Faraday, right? So here what they are doing, they are reducing this 1 mole of, see, 1 mole of what? 1 mole of MnO4 to MnO2. So what the reaction is? MnO4 is there, MnO4 minus, it has been reduced to MnO2, right? MnO2. So here we can calculate the oxidation state of manganese. How? X plus 4 into oxygen will be always minus 2. Overall charge is how much? Minus 1. So is equal to minus 1. So x minus 8 is equal to minus 1. X is equal to what? Minus it if it goes here, plus 8 minus 1 is plus 7. So oxidation state of manganese here is plus 7. Whereas in MnO2 you can calculate x plus 2 into minus 2. Overall charge of this MnO2 is how what? 0. So x is equal to minus 4 is equal to 0. So x is equal to what? 4. So oxidation state of this manganese in MnO2 is plus 4. So we see that plus 4 to plus 7 to plus 4 means how many unit change? 3 unit change, right? How many unit change? 3 unit change, right? So this we calculated. Why I calculated that oxidation state? See, it means if I put 3 electrons to this, it is going to convert to MnO4 minus. So here if I take 1 mole of this means 3 moles of electron I have to take. So it involves how many moles? 3 moles of electron. 3 moles of electron. If 1 mole of electron charge is 1 Faraday, 3 mole of electron charge will be how much? 3 Faraday. So answer is 3 Faraday. Option B is the correct option. I hope you got it, right? So this is about it. Question number 18. So question number 19. So they have given this reaction. 2SO2 plus O2 is equilibrium with 2 molecules of SO3. The rate of disappearance of O2 they have given. Rate of disappearance of O2 they have given. Right? Oxygen disappearance rate they have given. Mole per liter per second, the unit. And they have asked the rate of appearance. They have asked the rate of appearance of SO3. Right? So the given reaction, if you have studied this chemical kinetics in thorough, you can easily solve this reaction. So they have given this reaction. 2 molecules of SO2 plus O2 is in equilibrium with 2 molecules of SO3. Right? So this is the reaction. Right? So here the rate will be written like rate of SO2 minus will be like minus 1 by 2 into d of concentration of SO2 upon dt, which is again equal to rate of O2. Rate of O2 is nothing but d of O2 upon dt, which is again equal to, this is always minus. Reactant we will always take it in minus only because concentration will be decreasing, right? So at product side, this is product side, right? So 2 molecules of SO3, so it will be written as plus 2 means how much? 1 by 2 we have to take d of concentration of SO3 minus upon dt, right? So if we know any rate of this, if I know, I can easily calculate rate of this as well as rate of this. So if I know rate of this, I can calculate rate of this and also this, right? But here they have given rate of disappearance of O2. The rate, this rate they have given, and they have asked us to calculate the rate of appearance of SO3. We have to calculate the rate of appearance of this SO3. So how to calculate? So rate of disappearance of O2, they have given it to be 2 into 10 to the power minus 4 mole per liter per second, which is equal to rate of appearance of SO3. So it is equal to plus half into rate of SO3 into dt. Right. So rate, this is the rate we have to calculate, rate of SO3. So 1 by 2, if I send it to here, so it will becomes 2 into 10 to the power minus 4 mole per liter per second. So 2 into 2 is nothing but 4 into 10 to the power minus 4 mole per liter per second. So answer B is the correct option. 4 into 10 to the power minus 4 mole per liter per second. So that is the rate of appearance of SO3. I hope you got it. So question number 19, the answer is B. So talking about question number 20. So question number 20 is, which of the following electrolytes will have maximum coagulating value for this cationic soul? So this is cationic soul. What is this AgI bar Ag plus? It means there is a AgI precipitate like this, AgI precipitate, which will be having Ag plus ions. So the first layer will be like Ag plus ions, like this, right? So this is nothing but the collide. It will form a collide. So what is this coagulating value? So according to Hardy's Squenz rule, he tells that, so if it is a cationic collide, because Ag plus is a cation, right? It is surrounding this PPT, so it is forming cationic collide. The rule state that the negative charge anion, if it is 3 minus, it will be having greater coagulation power than the anion having 2 minus, than the anion having 1 minus. So that is about coagulation power. But there we'll study that coagulation power is inversely proportional to coagulation value. I hope you got it. So what is this? Coagulation power is inversely proportional to coagulation value. It means if I have greater coagulation power, the coagulation value will be less. If it is more, then it will be less, because both are inversely proportional. So coagulation power means what? Coagulation power is nothing but the, so for cationic soul, if the anion having greater charge, that can easily coagulate this, so it will be having greater coagulation power. So greater coagulation power means what is the coagulation value? Less coagulation value. So definition for coagulation value, less coagulation value. Why it is less? Because if I take only some milligrams, only 1 milligram of that anion is required to coagulate 1 liter of this collide. It means, so greater the coagulation power, lesser will be the coagulation value, right? So this relation, if you know, easily you can solve this. So here they have given, see, so this is cationic collide they have given, because AgI bar Ag plus means it is a cationic collide, right? So here anion, if you see, Na2 plus means S2 minus, sulfide is the anion. Here PO4 3 minus is the anion, and here SO4 2 minus is the anion, and here Cl minus is the anion. And the question is, which of the following electrode will have maximum coagulation value? They have asked. They have asked maximum coagulation value, not the power. So within this ABCD option, the more coagulation power is PO4 3 minus, because charge is 3 minus. So if I order coagulation power, I am writing now. Coagulation power of PO4 3 minus will be greater than what? SO4 2 minus, which will be almost equal to S2 minus, which will be again greater than Cl minus. So this is coagulation power, but they are asked coagulation value. We know that coagulation power is inversely proportional to coagulation value, right? So greater the coagulation power, smaller the coagulation value. So smaller the coagulation power, greater the coagulation value. So here coagulation power is greater for this PO4 3 minus, but lower for Cl minus, but coagulation value will be greater for Cl minus. So sodium cyanide is having greater what? Coagulation value, not the power. If they had asked power, then Na3PO4 minus was the correct option, because it is having more coagulation power, but this is having more coagulation value, right? You should know that, because both are inversely proportional, right? So this is about this video. So here I have discussed question number 15 to 20. If you liked the video, please give me a like button, share with your friends, so it will be helpful for them also, right? So subscribe the channel for continuing these videos. Thank